action. Hi, we are back with some more skills from first year chemistry. This is skills from first year chemistry 103, and we're talking about some more stoichiometry skills. And so for our part one today, we're discussing percent yield. And in order to introduce this idea, I always ask students to think of a time in their life when they got less than what they expected. And so maybe consider that for a second. When was a time in your life when you got less than what you expected? I always think of if you look at your paycheck and say you work like 10 hours at $10 an hour, your paycheck should be $100, but then taxes get taken out and all that stuff, and you get a little bit less than what you expected. And so with chemistry, it works kind of the same. When we look at product amount, we don't always get everything that's expected. And so we only get a percentage of what's expected in every chemical reaction. And so I'm just going to connect that here, and we're going to start with just a really simple balanced equation of the combustion of aluminum. So we're going to have aluminum solid plus oxygen gas makes aluminum oxide solid, and this is going to balance with a 4, a 3, and a 2. So we have aluminum reacting with oxygen to make aluminum oxide, and a question of percent yield would give you some grams to start with of one of the reactants, and then what's actually made, and then ask you for a percent yield. And so we're going to start with just a really basic stoichiometry calculation. Let's say that we have 25 grams of aluminum react in excess oxygen and let's see, what do I want to say? We'll say 18.5 grams of aluminum oxide are made, and we want to know what is the percent yield. So I'll give you a second to write that down. So what we want to remember with percent yield is that the equation for finding percent yield involves the actual yield, so what's actually made, over what's expected, and then we have to, of course, turn it into a percentage and multiply by 100 to get from the decimal to the percentage. Okay, so I'm just going to label this really quick. The actual, in this case here, is 18.5 grams. That's what's actually made, and that's what is told to you in the problem. That's what's actually made. What's expected is the answer to a stoichiometry problem. So we have to stoichiometry our way to what's expected. Kind of like if we were trying to figure out our paycheck, we would multiply our hourly wage times our number of hours to figure out our paycheck. So we have to figure out what's expected. And in order to do that, we're going to start with the 25 grams of aluminum. And we're going to first convert that to moles using the molar mass of aluminum. Scoot that up a little bit. And then we'll use a mole ratio. So we have 4 moles of aluminum to 2 moles of Al2O3. And then we want to get to grams of Al2O3. So we're going to do 1 mole of Al2O3 to 101.961 grams. That's the molar mass of aluminum oxide. So give me just a minute here and I will plug in the numbers. And so what I come up with is 47.2 grams are expected. So that would be the denominator in the expression for the percent yield. So our percent yield is the actual over the expected times 100. And our actual is the number from the problem, 18.5 grams. And then the 47.2 grams are expected times 100. So we get 39.2% yield, which is fairly low, but not all reactants become products in all cases. So we want to remember that for percent yield, we're always going to use the same equation, actual over expected times 100 equals the percent yield. Thank you.